Good morning. It is March 31st, Tuesday, and today we will be having office hours at 10 o'clock. I have posted the Zoom meeting information for you. Make sure you tune in if you have any questions. We're actually going to be looking at several things today. And I just lost my paper, but that's okay. I've got some notes here for you. Energy is actually going to be a big concept, and we're going to be looking at energy for at least 2 weeks. It's really important that we understand all of the nuances of energy. A unifying principle for energy, in terms of unifying the concept of energy with all other aspects of science, is that energy changes from one form to another, but it cannot be created or destroyed. The big idea that we're focusing on here right now this week is that energy has different forms, but it is always conserved. Again, we're back to that, neither created nor destroyed. And then finally, in terms of key concepts, energy exists in different forms, energy can change forms but is never lost, and that technology improves the way people use energy. I'm outside again in the garden, merely because sunlight is in fact life-sustaining energy. We exist, plants exist, our food exists, etc., everything because of sunlight and the form of energy that we get from sunlight. So the first thing we're going to talk about is how energy exists in different forms. And it has different uses. Energy is the ability to cause change. Different forms of energy cause different changes to occur. Mechanical energy involves the position and motion of objects. Mechanical energy is a combination of potential and kinetic energy. It can be either, or it can be both. Sound energy is energy associated with the transfer of vibrations through solids, liquids, and gas. Now, we've already studied sound as a wave. So we've taken a look at sound as a wave, as a longitudinal wave. But sound also has energy. Sounds cause vibrations, and that is in fact how sound travels. Chemical energy is energy that's stored in the chemical composition of matter due to atoms, bonds, and arrangements of atoms in substances. And we talked about this when we talked about glucose and photosynthesis when we were studying oceans. C6H12O6 is the energy byproduct of photosynthesis, and that is how plants and plankton generate their own energy. We also know that there's chemosynthesis. That is also a chemical reaction. Thermal energy is the total amount of energy within an object due to the motion of all the object's particles. So thermal energy is about how all the atomic bonds are moving, and that is the heat that's generated from the sun. When you feel your skin begin to prickle when you're out in the bright sunlight in the middle of summer here in Arizona, that's being caused by all the atoms that are heating up and are very agitated, bouncing off of your skin, that prickle. It's going so fast, and there are so many of them, that it's actually causing discomfort. Electromagnetic energy is energy in an electromagnetic wave. This includes visible light, ultraviolet light, X-rays, microwaves, and electromagnetic energy can travel through a vacuum. We know sound requires matter to transmit, light does not. So light is in addition to being energy, it's a photon, right? It's not just a wave, it's a photon. And then finally, nuclear energy holds atomic nuclei together. We talked about this a little bit earlier, a couple of weeks back, when we talked about the different types of forces there are in the universe. We've studied gravity a fair amount this year. We've talked about the electromagnetism, but I also told you that there's two different forces that govern the behavior and bonding of atoms, and those are small and large nuclear forces. And that is that nuclear energy that holds all of that together. And we are going to talk about that a little bit more as we study energy. Now, there are basically two general types of energy, and they are kinetic energy and potential energy. Kinetic energy, you'll see in the documents that we typically don't write out kinetic energy. We put it inside parentheses, capital KE. With potential energy, we put it into parentheses, and it's capital PE. We write it a lot, so it's just easier to use the abbreviation. Kinetic energy is energy of motion. The amount of kinetic energy that any object has will depend upon its mass and its speed. An increase in speed causes a much greater increase in kinetic energy than does an increase in mass. So two things affect the amount of kinetic energy that an object has, speed and mass, but the thing that affects it most is speed. So mass has less of an impact on the increase in energy than does speed. Then we have potential energy, and potential energy is stored energy. And it's stored in an object as a result of position, as a result of shape, or as a result of chemical composition. Now, there's several different types of potential energy that we're going to talk about. There's only one type of kinetic energy, and that's motion, all right? But with potential energy, the first one is gravitational potential energy, and that's due to an object's position above the Earth's surface. So gravitational potential energy is related to an object's mass and its height above the ground. So if I hold up this pen and I drop it, I release it and drop it, it has less potential energy at this height than it does at this height. So the height above the ground will increase the potential energy of an object due to the gravitational potential energy. We then have something called elastic potential energy, and this is due to position and shape of an object being compressed or flexed. And I want you to think about a squishy ball or an exercise band, okay? So that's elastic potential energy. Examples include springs, a stretched rubber band. Not every object that is compressed will contain elastic energy. For example, aluminum foil, when it's crumpled into a ball, has no elastic energy. So if you release it, it's not going to do anything. It's going to stay in that crumpled ball. Again, that has to do with the arrangement of the atoms. Chemical potential energy is due to a substance composition. The atoms and bonds contained with the substance, okay? So potential chemical energy is glucose or carbohydrates that we store in our bodies, right? If we're sitting quietly, we're not using much of our potential energy. If we're out running, we're using a lot of our potential energy as we convert those stored carbohydrates to energy that can be used by our bodies. So an example, so different substances contain different amounts of potential chemical energy. Examples include energy stored in fossil fuels, energy in molecules that's stored in food. So that those are the three basic types of potential energy. So we have gravitational, elastic, and chemical. Now, there's a couple of things that I want to clear up. There's a couple of misconceptions that we want to make sure we understand. The first one is about energy and matter. So you have to remember that matter is everything. Everything that exists is matter, except energy, all right? So heat, light, and electricity. Matter takes up space, and it has mass. Energy does not, and that's a key thing to remember in terms of doing that. The other thing that I want you to think about is energy at rest. So many students might think that objects at rest don't have any energy. Objects that are not moving do possess energy. What they possess is potential energy. All right, so a ball sitting on the ground has potential energy. It has the potential to move. The second misconception that we want to clear up is that we're going to learn about the law of the conservation of energy. So we already have talked about the law of the conservation of matter, which is that matter is neither created nor destroyed, it merely changes form. The same thing is true of energy, but I want you to think of the term conservation in a different way. Typically, at this point in your life, you think about conservation in terms of conserving, not consuming. So we turn off the lights, or you decide not to walk instead of drive in order to conserve fossil fuels, things like that. When we're talking about the conservation of energy, that is not the conservation that we're talking about. We're not talking about limiting consumption. What we're basically talking about is that it means the total amount of energy in the universe does not change. So the law of the conservation of energy means that all of the energy that we have in the universe is all of the energy that we're ever going to have in the universe, all right? So that is what we mean. So conservation of energy, the law of conservation of energy basically is that all of the matter that we have is all we're ever going to have, right? It doesn't have anything to do with reducing consumption to conserve what energy we have here on Earth, or the potential energy that we have here on Earth, okay? So those are two very key things that we want to talk about. So to put it in a very simple terms, remember that kinetic energy is energy that an object has because it's moving, and potential energy is stored energy. And I want to talk about this in terms of, I want you to think about a swing, a child sitting on a swing. You're going to take that swing and you're going to pull it back, right? And you're going to hang on to it. And while you got that swing pulled way back, you have potential energy, all right? It's not in motion. You're just holding it. The minute you let go of that swing and it moves forward, you now have kinetic energy. And we're going to look at how we measure that. So the potential energy of an object is going to have to equal the kinetic energy of the object, okay? So that swing is only going to go a certain distance, and then it's going to stop, all of its kinetic energy expended, but then it can come back, because once it's up and it's stopped again, we have gravitational potential energy. The minute you let go of it again, it swings straight back. And again, the amount of kinetic energy is going to be the same amount as potential energy. You're going to get a worksheet today that will have a series of examples, and I want you to think about those examples and indicate whether they are kinetic energy or whether they're potential energy. You're also going to get a vocabulary worksheet today that's going to have you identifying and defining the different types of energy that we're going to study. And those different types are mechanical, thermal, light, sound, electrical, chemical, and nuclear. Those are all terms you can easily find on dictionary.com, so you don't need to worry about having a notebook. Right? These do need to go in your notebook, however. Please put these terms in your notebook. And for example, chemical energy, the definition I have for chemical energy is the energy stored in chemical bonds. All right, the energy stored in chemical bonds. That's really simple. You only need a one-sentence explanation for each of these types of energy. They're really quite simple. All right. Well, I hope to see you all during office hours, and make sure you have questions. And we're going to talk about protocols for the office hours and go over some of the concerns that you've had regarding homework. All right. Talk to you later. Bye.